हरिः कर्ता।
Now let's look into the few more examples of interval data. So other examples of interval level data may include time in seconds or minutes measured from a specific point in time, and second, pH level, which ranges from 0 to 14, where each unit of difference is meaningful but there is no true zero for the pH. And standardized test scores like SAT or GRE, where scores range from a minimum to a maximum, but a score of 0 does not represent a complete absence of the attribute being measured. And then the fourth one, the Celsius or Fahrenheit temperature scale, where the difference between 10 degrees and 20 degrees is the same as the difference between 20 degrees and 30 degrees, but 0 degrees or 32 degrees Fahrenheit is not an absolute zero temperature. So 0 degrees is not an absolute zero temperature. So 0 degrees means it's low, and it's low and cold. Okay, so now let's explore the interval level data. Now let's analyze the interval level of measurement or interval level data using the statistical measures that are available for them. So interval level of measurement, you have the following statistical tests: t-test, ANOVA, Pearson, or linear regression. So, and the descriptive statistics that we can use, as usual, frequency distribution is used for all of the levels of measurement. Then the mode, median, and the mean. The mode is only for nominal, and the mode and median for both nominal and ordinal. And then mode, median, and mean can be used for the interval level of measurement also. These three attributes, or these three measures, are known as um, a measure of central tendency. Then you have range, then standard deviation and variance. These are all measure of variance, measure of variability. Okay, so these are the different measures we'll be using from frequency distribution. It's these are called summary statistics. Frequency distribution gives the summary of your data. Then you have measure of central tendency. Then after that you have measure of variability. So let's look into the, let's call up a data first. So let's read tabular data. So I'm gonna use a temperatures data. So temps is equals to pandas dot read CSV, and inside the read CSV I'm gonna take a file. So let me go for the time series directory, and inside that I'll go for the time series. Okay, electric production daily minimum temperatures in ME. Okay, execute, and let me see temps. Yeah, so like we have some nans. So what I'm gonna do is I'm gonna drop off these nans. So I don't want this nan values, so I'll just drop these nan values in this. So wherever is there, temps, and drop. Okay. Okay, each row has been dropped. Okay, forgot to put that specific. Sorry, that's my mistake. Unnamed Yep, the series itself is removed. So now I'll make it into temperatures. So let's do other thing. In spite of this, I'm gonna go for, so date, then daily. So my temperature, okay, now I got it. So date, so let me make it temperatures. Yep, so this is what my final data. So these are my temperatures that you can see. So temperatures dot head, and 20, 21, 18, 19, 15, 16. So for each 1 degree Celsius there is a clear cut differentiation. Okay, and these are the last values. And when you say 0, 0 doesn't mean there is no value. 0 also has a particular value. So these are called basically or interval data. So now let's we have seen the data. Now it's time to do the required analysis. Okay, so let me scroll up first. So we'll begin with the frequency distribution. So let me go for the frequency distribution. So temperatures, it's daily minimum temperatures, and values value counts. Yep, so if you see the value count, so 11 degrees Celsius has come 347 times. So that means 11 degrees Celsius was recorded 347. These are daily minimum temperatures, 347 days. And 10 degrees Celsius was recorded 344 days, and 13 degrees Celsius was recorded 344, again 334 days. So 11, 10, 11, 10, 13 are the temperature which are heavily recorded, which are recorded heavily. And other than that, if you see 26, this is the minimum temperature, so that recorded only once. And you have some value without any specific values, and 0 degrees Celsius was also recorded 4. This is what I'm saying. When you say 0 degrees Celsius, it doesn't mean it's a true 0. It doesn't mean it's a true 0. No, it's not a true 0. It has a certain value. So here 0 means it's low and cold. It's colder than 24 degrees Celsius. Okay, so that's what the 0 means. So here the temperature, basically this means that there is a meaningful difference between differences between the values and can be calculated. So that's what the main thing. So let's we have seen, let me write down this is our frequency distribution. Frequency distribution. Okay, So now let me plot. So let me copy the same one, paste it here. In spite of that, I'll go for the list. Yep. And this is the frequency distribution of our data. And then obviously the 9, you can see that from 14 to 7 degrees Celsius is has been recorded too many days. So this has been heavily recorded from, so minimum temperatures from 14 to 7 degrees Celsius is widely recorded, whereas other temperatures are very less. If you see uh, 23 26 degrees Celsius, again it's very less, and 21 18 19 16, these are also very less. So okay, so this 8 to 8 9 10 7, these are widely recorded. This is what is our frequency distribution that you can see here. You have the temperatures on left side, you have your frequency. So now let's look into the central tendency, measure of central tendency. So measure of central tendency, and the first one is, as usual, it's a mode. Okay, so let me paste the same one, same code. So let me remove this, let me get the mode. Again, the mode is the, it returns the mode of each column of a data frame or series if you directly give it to the pandas data frame. But here I'm directly attaching this method, I'm calling this method specific to a series, so I'm gonna get the mode of this series. So mode of this series will give you give you a value, give you a temperature which has been recorded, uh, which has been recorded heavily, which has been recorded highest. So 11 degrees Celsius was recorded in 347 days. So that is the reason. So the mode of this data is 311 degrees Celsius. So then we will see median. So median, as we have discussed earlier, so median is the, if you put all your records, all your data points in a series, uh, in mm, a series in ascending order, exactly the center data point is our, the center record is our median. So let me check here also, let me paste it here, and then in spite of mode I'm going to use median. Okay, could not convert a string to float. So let's check what is interrupting us to calculate the median. So what I'm gonna do is, so I'll just copy this one and I will look into the unique values of daily minimum temperatures panda series. So unique. Okay, so you got all numbers, numerics other than this, we got the value. So one value, so I'm gonna copy this exactly. Yeah, and we have a lot of different types of we can group different we can group all statistical methods in pandas, such as descriptive statistics, and data aggregation, data transformation, data visualization, correlation, and regression. So now we'll be using a replace method from pandas, which is grouped into data transformation. So let me save it into an X. So what I'm gonna do is I will take uh, just temp series is equals to temperatures, daily minimum temperatures dot replace yeah, got it. So replace in this, I'm gonna replace this with just just will keep it as a none value. Okay, we'll put it as a simple value and it will work. Okay, let's do that, or you can put it as 0 also, whichever that works, but here 0 doesn't work because 0 means again it has certain uh, value and certain weightage. So temp series, and here is what your data, and let's cross check the unique values of it again, and here is that we got the none, other than that nothing else. Okay, done. So now what will we do is let's calculate temp seer dot median, and here is that you got the 11. So this is how we calculate the median for it's a measure of central tendency, and this is how we calculate median for interval type of data, interval data. And here we have calculated the mode also, that you can see mode we got 11, and median we got also 11. So now again mode, mean, median, mode all comes under descriptive statistics. I have told you there are five sections of five groups of statistical methods. One is descriptive statistics, data aggregation, data transformation, data visualization, correlation, and regression. So mean, median, mode, count, variance, standard deviation, all this comes under descriptive statistics. Okay, so and again those are also subdivided into uh, mean, median, mode comes under central tendency, measure of central tendency, variance, standard deviation comes under measure of variability, and then you have min, max, this comes under the range, and this also min, max, and range comes under measure of variability, and then we have yeah, that's how these will be subdivided. Okay, so now let's look into the one more method that we want to look, and that's what let me put into the slide. Okay, so mean, sorry, in this median, mode are covered. So mode and median are covered. Next thing that's left for us is median, and let's do median, let's do mean, and then we'll see what's going to happen. So next is mean. So mode, median, both are done. Now it's time to look into the mean. Yep, so we'll take the temp seer dot mean, and it's what is this, just a minute, let me check. So numpy, this is float 64. So obviously if you see all these objects, all these objects which are part of, or elements which are part of this array, or pandas data frame, are string objects. So that's the reason we are unable to do the mean calculation. Okay, whereas a mode calculation, whereas median calculation, it is not a big deal, so it can be done because they all will be put in sequential way, in a uh, in a sequential way. So like so whichever is exactly at the center, that element will be chosen as median. But whereas here it has to do the calculation for that, it needs to be an int or float. But if you see data type of sorry, data type here, it's not int, because this is 2118. You can clearly see it's wrapped in between, it's wrapped in between the single quotation marks. So what I will do is I'll take temp series 1 and temp series as type. Let me convert this into int. So now temp series 1 and execute, and here is what you got, the int. See, if you are still doubt, let me show you. Unique, and here is that, absolutely into values. So now let's do the mean of this. Temp series 1 mean and execute it, and we got it 11.24027397260,274. So one more time I am reiterating, this is comes under descriptive statistics, and this is inside the descriptive statistics, this is called the measure of central tendency. So that's it. We have covered three measures of central tendency from uh, for the interval data. So frequency distribution we have seen, and then measure of central tendency, the mode, median and mean we have seen. So now we'll see the measure of variability. We'll begin with the range, and we will get into the standard deviation, and we'll get into the variation later. So what I'm gonna do is, so I will take I'll write it down as measure of variability. So I'll put it as 3, and inside that the first one is a range. Okay, so now so range, the range comes under measure of variability. It will tell you how far and how much the data has been, from where to where the data has been distributed. For that we use this. Okay, so let's use a range method to let's use a min max methods from pandas to find out the range. So what will we do is, we will take min max, calculates the, let's calculate the min and let's calculate the max both. Okay, so we have temp series 1, and then I'll go for the min. This is the min value. I'll go for the temp series, and then I'll go for the max, and this is the maximum value. So now the range is equals to, so this is what is our range. So temp, oh sorry, yep, this is what is our range. This is the total range of temperature distribution there. So now let's look into the standard deviation. To standard deviation. So what is standard deviation and all, we will be looking into that standard deviation in detail in statistics course, but for now we will just use a method from pandas to calculate the standard deviation. So let's take just a minute. Yeah, so temp and then standard deviation, and here is the standard deviation. So the standard deviation from, or the deviation from one element to any element in that data in that records is generally 4.075. so that's what the general deviation from one element to other element in total. Okay, so that's what is our standard deviation. Then we have our variance. So now let's also calculate the variance. So all this will make you understand about the data. So these are all descriptive statistics. Whatever we are doing so far, these are all descriptive statistics. In descriptive statistics, we call them as a measure of variance, a measure of variability. So, so let me take the same one, and then I'll use var method, and this is what the variance is. Variance is obviously root of it. So standard deviation is a root of var. So obviously, so variance is a square of standard deviation. So that's the reason this is 4.0756, and then other one is 16.616. Okay. Yep. 16.61120.295, because standard variance is the square of the standard deviation, or in other way, standard deviation is the square root of variance. Okay, so that's what the standard deviation and variance, and these are the different methods that we can use. These are the different descriptive statistics that we can use to understand the interval data better. So this is what the descriptive statistics we have seen so far, and on top of that we have some statistical tests, and all these statistical tests will be looking into when we start with machine learning.